You've been introduced to the idea of working with a recurrence relation in the last lesson. Those recurrence relations took the format that you can see there, un plus 1 equals a, un, where that a value was usually worked out by a percentage statement that you were given. What we're going to look at today is our recurrence relations, which have also got a constant term as well as a variable term. The un is a variable term that's constantly changing. You work out u1, then you work out u2, and so on. So that's called a variable where that changes. And what you're going to be looking at today is expressions or recurrence relations rather, which take this sort of format here: un plus 1 equals a, un plus, and then it can sometimes be a minus as well, plus or minus a number onto the end of that. I'm saying here, notice that actually that kind of format where you've got a number times a variable plus a constant, it's very similar to the straight line equation, y equals mx plus c. So for that reason, you will see that we refer to these types of sequences that we generate from this as linear recurrence relations. And there's lots and lots of practical applications of this. We can use linear recurrence relation to model certain real life situations. So we're going to look at one example where that would be the case. So this one here, patient is injected with 156 millilitres of a drug. Every 8 hours, 22% of the drug passes out of his bloodstream. To compensate, a further 25 millilitre dose is given every 8 hours. And you have to find a recurrence relation for the amount of drug in the bloodstream, and then you're asked to calculate how much of the drug would be remaining after 24 hours. So your starting point for this is for you to come up with the recurrence relation that would model this particular situation. So I want to think about the fact that that initial dose that was given was 156 millilitres of the drug. What do we know? We know every 8 hours there's another 25 millilitres is being added in, and we do know that 22% of the drug is removed, or not removed, but it leaves the body rather, which would leave you, if every 8 hours you've lost 22% effect from the drug, then that would leave you with 78% of the drug still in the system. So you've got this 100% minus the 22% would mean that you're left with 78%. But then we know that together, so we've got this 0.78 amount left, but we're also getting this plus 25 added in. So that's where this extra part of your recurrence relation comes from. So this time, there's the UN notation again. That represents the amount of drug in the bloodstream after, not just after 8 hours, because it's been measured in lots of 8. So it's 8 hours for this one, because it's happening every 8 hours. So 8 hours, then 16 hours, and so on, when n equals 1, 2, 3. So there's your recurrence relation, and then from that you're asked to work out what how much drug is there after 24 hours. So after 8 hours, that's the first lot, so that's your n equals 1. You would do this 0.78 times your starting value, 156, plus the 25, you get 146.68 millilitres. That amount is then in the body, but then we know that 22% is lost, so you're left with 78% of that after another 8 hours. So you'd have 78% of that 146, but plus they're also being given another 25 in. Now on the calculator, You can still use the quick equals method, just pressing the button, etc., to generate the sequence, but remember we need to see the working written out. So you have 156 equals, you put in your times by 0.78, and you also need to put that plus 25 in there, and then thereafter you can just press the equals button to generate the sequence. So after 24 hours at this point here, you're using the value from the 16 hours. It carries down. So we can clearly see after 24 hours that we'd have 133.74. There's a whole load of digits there. You should list at least 4 of them and then show that you've rounded. So remember, this is kind of question where you've got a problem, then you need a statement, right? Something that actually makes sense and answers the question. So a full written statement after 24 hours, the patient will have 133.74 millilitres of drug in their bloodstream. So that is one type of practical application of what we're doing. You can model these real life situations with these linear recurrence relations where it's the same percentage happening over a period, but there's also now an add-in factor, or sometimes it might be a minus factor. In the case of something like a bank loan, for example, where you've got this, you're being charged interest but you're paying some of the money off, then where we've got this plus 25 bit, that could become a minus depending on how much you're paying each stage. So it won't always be add on, it might be take away, but it's still a recurrence relation. So here's an example here, a second one. You're just given the recurrence relation, not any practical application going on here, but it's just a wee bit of practice with the notation. So you're given that statement, you're told the U0 value, and you're asked to calculate U3. And a second part of this question is you're also asked to calculate the smallest value of n for which the UN value will be greater than 9.7. So you're working for this just before we actually get to the calculator part, just to think through what's the recurrence relation telling you to do. So if you're working out the first value, that would mean you'd need to be replacing the n number with U0. Right, 0 plus 1 would give us U1. So to work out U1, we're going to be doing 0.6 times the U0 value plus 4. To work out U2, it will be 0.6 times the U1 value, and so on. Right, that's all the recurrence relations telling you. It's using the previous term to get the next term. So what does that look like for us number-wise? Remember that on the calculator, you would put in your 7 and then press the equals button. So you'd have 7 equals, then you would want to put in times by 0.6 and then press plus 4 and then equals, and then just start to press equals after that. But we need to see the working written out here. So the fact that I've got sums written out is essential. So continuing right, that sequence down, so the value of U3 would be 9.352, which is one of the questions. Right, work calculate the value of U3, so 9.352. I've just left it because it's worked out exactly. I didn't do any rounding with it. If you continue the sequence, then you would end up with a U4 equals right 9.6112 and so on, your U5, and then you can see that we're looking for whereabouts, right, do we end up being bigger than 9.7, and it's at the 5th value here is the first place that we end up being greater than 9.7. So UN greater than 9.7 would be when n is equal to 5. And that would be your final statement. So make sure when you do these questions with linear recurrence relations, you can or you need to show at least minimum 3 lines of working like I've done here, the first 3 calculations. Thereafter it is okay to list the values. You don't need to write repeated all the work in. But you do need to demonstrate what the recurrence relation is. When you state your recurrence relation, you should also include the initial value.